Morning, everybody. Nice, a response this time. Usually I get no response. Anyone have any questions before we start today? So, if you got up this morning and you made the effort to come to this workshop today, you will not regret it. This is a great day to be here because we're going to start coursework 1 today, basically. So, it's about extracting the essentials of the research paper, and we had a lecture on this topic. The lecture on this topic, it said like what to extract, you know, the concept, the implementation, the core related work, the evaluation type, like a short description of the implementation. However, I didn't really demonstrate how to do that. I only said what to do. So I'm going to give a little demonstration as to how to do that today. But before I do that, so this is the workshop today. We're going to form groups of 4 to 6. That's a big shock to everybody, I'm sure. You're going to choose one research paper from that URL. I'm going to look through them. And then you're going to start a Google Doc. Surprise, surprise. And you're going to add each name of each group number to the top, and then you're going to extract the essentials of a research paper using the template provided in coursework 1. And then you share your results. That's the idea. And I'm going to provide some feedback. But before we do that, I thought I would just do a live demonstration of this process, you know, while you can watch, right, to see, and I'll use a think aloud protocol to try to convey what I'm doing with you. Yeah, does that sound good? Because I've had some practice at this. We can even have a race. No, I hate races. But it would be a funny race, like who can do it the fastest sort of thing. So I downloaded a research paper already. You can find a copy of this on Moodle. So there's the research paper. I will zoom in. It's called Squarified Tree Maps. I'm trying to zoom in so you can all see it. Maybe that's a little bit too zoomed in. And then I have coursework 1 all fired up. There's the template we're filling out, right? I will just copy and paste it, and then I will start the exercise, right? So luckily I've picked a paper with a short title, so that's not too difficult. Squarified tree maps by, and then these guys. These guys are Dutch. Okay. So let's see, I'll just make the font a little bit bigger there. So that part wasn't too hard, was it? To get the title and the authors. Now the concept, what is the concept? Anybody know where I'm going to look for the concept? Where I would look to get that? Anybody have any ideas? I can find the concept in two places, the abstract and the introduction. So I will scan the abstract and the introduction to extract the concept. Yeah. So an extension to the tree map method for the visualization of hierarchical information such as directory structures is presented. The standard tree map method often yields thin, elongated rectangles. As a result, rectangles are different to compare and select. A new method is presented to generate layouts in which the rectangles approximate squares. To strengthen the visualization of the structure, shaded frames are used around the groups of related nodes. So I see the concept there. It's a little bit terse, right? There's not much detail there. So maybe I will look at the introduction. I have the concept. I can extract it because I've had so much practice. But maybe if I wasn't having so much practice, I would look at the introduction to try to understand it a little more. So we're talking about hierarchical structures, right? So this is about hierarchical data. Tree maps are a way to visualize hierarchical data. Oh, but look, you know what? While I'm looking for the concept, I've got the core related work right there. The authors have made this nice for us. They've explicitly given us the core related work, which is not very common actually. But the core related work is right there. So I can already put in the core related work there. I should probably make this a little bit bigger, shouldn't I? So there it is. So while I was looking for the concept, I stumbled upon the core related work. Okay, so this paper we attack another problem of standard tree maps. So they're specifically saying a problem that they're trying to solve, right? The standard tree maps, the emergence of thin, elongated triangles. We propose a new method to subdivide rectangular areas such that the resulting subtriangles have a lower aspect ratio. These rectangles use space more efficiently, are easier to point at in interactive environments, and are easier to estimate with respect to size. So that is the concept again, presented again. So I'll put that in there. So the concept is the authors present an improved version of the tree map by reducing the aspect ratio of the rectangles used in the layout algorithm. And if I want, I could just leave it there. I'll add another sentence. They attempt to generate square rectangles for the tree map layout algorithm. So that's the summary of the concept. Right, so I already have three aspects. I got the paper title, I got the concept, I have the core related work. But now the implementation, this is the difficult part. In some ways, Yeah, I guess this is the most difficult part. How do you come up with a 1 or 2 sentence summary of the implementation? Because most of the papers are about the implementation. You get lost in the details of the implementation, right? Does anybody know the answer to this question already? I would be really surprised if you knew the answer already. That would be shocking. You'd have to had watched the video, previous version of this lecture already. So if the paper is written well, the authors will provide a summary of their implementation in just a few sentences. You can look at the implementation section, and the implementation section will provide a summary of the implementation right in the beginning. If it's a well-written paper. It's not guaranteed to be that way, but if they do a good job, that's the way it will be. So let's look. So I got my introduction. This is where I find the concept. Background, okay, that's a little bit about how tree maps are constructed. And that is, by the way, these are typical tree maps here. And then, okay, here is where they start to discuss the implementation. Yeah. And basically, this is where all the details are, right? And that's a summary of the implementation. But let's see if we can do this. We can summarize. So those are the squarified tree maps, by the way. See how the rectangles are more approximating squares in this example? And there's shading being added to the tree maps. But let's see if we can just capture the essence of the implementation in 1 or 2 sentences. And we will look at this squarification section. How can we tessellate a rectangle recursively into rectangles such that their aspect ratios approach 1 as close as possible? So the number of all tessellations is very large. This problem falls into the category of NP-hard problems. However, for our application, we do not need the optimal solution. A good solution is what we aim for. We have experimented with many different algorithms. We present a method that empirically turned out to give the best results. The key idea, look, there they are. There it is. The key idea is based on 2 notions. We do not consider the subdivision for all levels simultaneously. This leads to an explosion in computation time. Instead, we strive to produce the square-like rectangles for a set of siblings. Right? Second, we replace the straightforward subdivision process for a set of siblings of the standard tree map technique by a process that is similar to the hierarchical subdivision process of the standard tree map. So that's not a very good summary of the implementation. That's not. I thought it would be a good one. So I'm still looking for a good summary. I'm still looking. This is kind of a summary right here. This picture is a kind of summary. So my summary is going to be based, so this is the tricky part, right? This paper is not giving us really a very good summary of the implementation. So I'm looking at the description, right? That's the standard. This is the standard layout algorithm. And then I'm just reading here to see if I could find anything. So this is going to be my summary of the implementation. The authors choose a greedy algorithm by starting with the largest sibling node. They place the rectangle using the standard tree map layout algorithm, and they compare that same placement with a squarified version, and the result with the aspect ratio closer to 1 is chosen. So that's my summary of the implementation. That's the difficult part, by the way. So they do two tests. They place a rectangle using the original tree map layout algorithm, but then they also try it with the squarified version, and then they see, okay, which one has an aspect ratio closer to 1, and then they choose the one with the aspect ratio closer to 1. So that's the difficult part of this exercise, by the way. So what I just did is difficult, right? That's the difficult part of this. Trying to take that complexity of the implementation and reducing it down to 2 sentences, a 2-sentence summary. That's the difficult part. Gesundheit. So I have the paper title. This really should be 1. Why is that? This should be 1. I don't know why that's not 1. That's annoying. Anyways, this should be 1. That should be 2. This should be 3. Core-related work. They gave us the core-related work. Normally you would see that in the related work section. Input data characteristics. So they told us that already. They told us that in the introduction, what the input data is. So there's the input data right here. They told us that in the introduction. It's hierarchical data. Right. So the input data is hierarchical data of any kind. Yeah. Type of evaluation. Anybody want to guess what the type of evaluation is? Anybody feeling brave? If I look, so there's the original tree map layout algorithm. See the long rectangles? Long with high aspect ratios. This is the original, right? And you get these long triangles, rectangles. That's the summary of the new algorithm. And that's what the new algorithm looks like. So the way they perform their evaluation is what we stated in the first slide. It's a performance comparison with the previous tree map algorithm. That's what it is. And actually, it's a visual comparison. It's visual. Yeah. So they're not comparing speed of the algorithm. They're comparing the output, like the way it looks. So they're not comparing speed, they're not comparing accuracy, they're not comparing memory requirements, they're comparing the visual output. So the performance based on the visual output with the previous version of the tree maps algorithm. That's the evaluation. And anything else? Representative images. What's a nice representative image? So I can copy and paste a nice representative image. I guess something like this could be good. This could be a nice representative image here. Put it in there. It's a little bit big. And then the DOI. Anybody know how to get the DOI? Maybe somebody's feeling advanced enough. Anybody know how to get the DOI? I'm surprised nobody knows how to do that. That's not that difficult of a question. Anybody remember what a DOI is? Digital Object Identifier? You have your hand up? How do you get the DOI?
Basically, like the URL. So you go to the article, there'll be a DOI code right there. Like, you just click the article and just
I wouldn't recommend that.
sometimes it's written on the paper.
Sometimes it's written on the paper, that's correct. Squarified tree maps, DOI. Hopefully we get the DOI from that kind of query. So is it there somewhere? Should be here somewhere.
If you click site as,
Yeah,
site as, it should be there.
Where do you see the site as?
On the top. Right.
On the top.
No, below that. Slightly.
Oh yeah, there. Yeah, there it is. DOI. Yep. So you can just Google the DOI. Right. There it is. And then the URL to the PDF is there. Okay, everybody think they can do this exercise? I'm not going to advertise it as easy. I'm not advertising it like that. I guess the difficult part is really the summary of that implementation, really. That's what it is. Otherwise, I think that's the difficult part. Otherwise, I don't think the other stuff is too difficult. Yeah. And probably I just took 20 minutes or something, maybe 15 to 20 minutes to do that one. Sound good? So that is your exercise for today. And I will make the groups. If you have questions, by the way, during your work, you can ask the questions. Not many people are really asking questions during the work time, during the workshop time. Okay, let's start then. Before